Hey guys, today what we're going to talk about is making predictions within exponential data and sometimes linear, but mostly exponential today because we learned about it yesterday. So we're combining a couple of new things that we've talked about this chapter into one little lesson. So what we're going to do is make sure you have packet 10 out, a calculator and a pen or pencil. If you don't have the packet printed out from the Google Classroom, pause the video if you need to. Before we start, let's just recap what we learned so far about calculating exponential regression equations. So what we did is we definitely made sure our diagnostics were on by pressing mode and scrolling to get diagnostics on. And then we pressed, put our stat and edit, and then plugged our data into list 1 and 2. And we compared StatCalc 0 and StatCalc 4. Now, StatCalc 4 was our linear regression equation, which we did before, but yesterday we learned a new one, StatCalc 0, which was our exponential regression equation. Just remember when you're plugging it into an exponential regression equation, it looks something like this. Many mistakes were made yesterday where you put X's and plus signs. I actually wrote linear regression equations as opposed to exponential ones. So be careful that you hone in on that today. Okay, so what we're going to do is make sure that you're on top of page 8 in packet 10, and we're doing the regions question. So stop to make sure that you have that on your page. So this is what the question looks like. It says about a year ago, Joey watched an online video of a band and noticed that it had been viewed 843 times. 1 month later, he noticed the video had 1708 views. Joey made a table below to keep track of the cumulative number of views the video was getting. Write a regression equation that best models this data, and then round your answer to the nearest hundredth. So before we get started, the reason why I wanted to do this is because he forgot to record this data. And generally, I have a conversation about that in class, but we can't right now. So what we do is we just eliminate this from our data when we're plugging it into our calculator. So when we're plugging into list 1, list 2, we go 0, 1, skip over 2, and then put 3, 4, 5, and so on and so forth. So first, what we do is just make sure your diagnostics are on when you press mode and check. I know we said that before, but just make sure it's on now. Then what we do is we're going to plug the data into list 1 and list 2. And for those of you that didn't listen, we're skipping over 2 when you plug it in. So on your paper, make sure you plug into list 1 and list 2. Pause the video as you do that. Then we're going to look at our R values because we want to see which is the best equation. So first what we do is we're going to press Stat Calc 4 and enter in our calculator to get our linear regression correlation coefficient. Will tell us how strong it is. And you should get a decimal of 8.8633407. Please make sure you pause the video to do this in your calculator if you haven't done so already. Now we're going to same data. We're going to press Stat Calc 0 and enter and look at our R value. And that's 0.9999986. That's why I went really far over because it was super, super strong. So make sure you have this down on your paper. If you don't have it or have no idea what I'm talking about, please go back to yesterday's lesson and watch it over to kind of get what the whole idea of calculating the different regression equations was about. So since we found that that was the stronger value because it was closer to 1, some of you were still having a hard time. Think about a test grade. This is a 99. This is an 86. This is closer to 1. The exponential regression value is definitely the strongest, so we're going to use that to represent the data. So let's go back in and press StatCalc 0 to get it on our calculator again. And when we round it to the nearest hundredth, which is our second decimal spot, your regression equation, which is exponential, should look like the one below. Y equals 836.47 parenthesis 2.05x. That's how you write an exponential regression equation. So that was the first part. And again, this was a part 2 regions question. Then the next part said, as shown in the table below, Joey forgot to record the number of views after the second month. So using your equation from part A to estimate the number of full views of it's supposed to be online video that Joey forgot to record. So we're going to write our equation down. Our equation is y equals 8.36.47 parenthesis 2.05. Now they want us to record what do you think the second month would be. Now since months is this column, it represents our x, we're going to plug a 2, which represents second, in for x, just like you see there in blue. So once you replace that x with 2, pause it if you didn't do so, you're now just going to plug this expression into your calculator. Type it into your calculator, pause the video to do so, and you should get 3515.265175. And now they want you to do it to full views, so that would be a 3.515 or 3.516 if you want to round it up. But in this particular case, it doesn't really matter because it's just viewings. Okay, so we're using these to predict, and that's what you're going to do for the next couple examples. So if you haven't done so, make sure you copy all the notes from the video, flip to the next page and complete numbers 2 and 3 on the next page, and then you're going to skip 4, and then you're going to go to number 2 on the homework page, which is right after that. And then when you're done with those questions, just make sure you work on the test review, and we'll go over any of those questions at our Zoom meetings. Please just submit only one picture of the problems that you completed so I could just assess whether or not you got what we were talking about today. And please make sure your name is on the page before you submit it, because some days I'm getting emails from random email addresses and I have no idea who's sending them to me. So please make sure your name is on it. Thanks, guys, and can't wait to see you tomorrow at our Zoom meeting. Bye.